All right. In today's Coding Under 60-Minute challenge, I'll be solving Leetcode questions, but particularly I will start from the easy questions, and then, there's going to be another playlist for medium or hard questions if I can do those. But yeah, let's start with Leetcode, and then I just signed in with my Google account, and then we can go to problems. And the way I like to solve it is basically doing algorithm questions because they have database, JavaScript questions and stuff like that. So you just click algorithm and then easy. And then what I like to do is sort it by acceptance rate. So basically these should be easy because, the acceptance rate is so high, right? But I mean, it's not always like that. It depends on the test cases and stuff, but usually it's kind of like this case. So I'll be just going top to bottom, and then I'm going to be skipping the premium questions. Most of us don't have the premium account, right? So let's just go ahead and start solving these, but let's just try to solve at least 10 problems in an hour. I'm pretty sure I can do those 10 problems because they're easy, and also I've done a lot of Leetcode questions in the past, so some of them would be really, really familiar to me, and hopefully I'll just blaze through it, right? So yeah, I have the stopwatch, and let's get started. So yeah, just a couple of notes before I begin. I'll try to solve it as optimal as possible, but if not, then I'll just solve it that is accepted by Leetcode, right? If it's accepted by Leetcode, I'm fine with it, honestly, but I'll try to solve it as optimal as possible too. Okay, let's start. Okay, let's go. Intersection of two arrays. I'm not sure what this means. Status, maybe it's daily challenge or something. Okay, whatever. Not sure. Okay, enable dynamic layout, whatever. I'll just skip it. And I think there's like a shortcut where you can do like control enter, where you can just submit it instantly, and then control quote would be just running the code, right? So we'll pick Python, and I recommend everyone you to use Python for interview questions, by the way. So because it's just much easier to code, and it's really, really fast. Okay, so it says intersection of two arrays, given two integer arrays, nums1, nums2, return the array of their intersection. Each element of the result must appear as many times as shown in both arrays, and may return the result in any order. Okay, so I see. So basically like intersection of two arrays, I guess that's self-explanatory. 9 and 4 is also accepted. Okay, so the order doesn't matter. I guess the brute force way of this would be just doing for loops, right? Like 2 times nested for loops, and then just solving that way. But I think the optimal solution would be just use hash map and then doing counters, right? Like count the number of elements and then just reproduce the array. So let me just show you the optimal way first. So let me just do like map 1 would be your nums1 array. No, sorry, the count, right? But map 2 would be your count of the numbers too. But also in Python, this is the way you would define hash map, but you can just do it this way, default dict integer, right? There is like a couple of advantages of doing default dict. Let me tell you why. Okay, so let's do like 4 and in num1, and then you can just do like n plus 1. So this is just gonna give you the counts. Then let me just print these and return the empty array, and then see what's up, and then I'll try to explain what this default dict does, right? Okay, so default dict, it didn't print anything. Let me see, nums1, oh wait, maybe, okay, no, map 1 of, this is so weird, nums1 for, oh, sorry, I'm just printing map. I have to print map 1. Okay, there you go. Okay, now it says, okay, number 1 is 2 times and number 2 is 2 times, right? Which is exactly what we want. So, okay, so if I do like just empty dictionary, right, I cannot do this anymore because it will just complain that the key doesn't exist, right? So yeah, so the key doesn't exist. But default dictionary, what it does is like, hey, I'm just saying, if the key doesn't exist, say it as initialize it as integer, which is just 0. The default value of integers is just 0. So that's why I can do this. If this key doesn't exist, treat it as 0, and then we just add 1, right? So which is exactly what we want. Okay, I'll just do this. And then, okay, so we have map 1 for n in nums2, map 2 of n plus minus 1. And then we can just loop through any of the maps, right? So we can do like, let's just do key value. These values doesn't matter, but you have to do like, in order to loop through maps, right, you have to do like these. So items will give you the keys and then the value like consecutively. But if you just do like key like this, then it's just gonna give you the keys, right? But if you do this, it just gives you like the key of value together, which is really nice. And then I just do like, okay, if key is in map 2, then which means we have intersection, right? So okay, we have intersection, then we can just do an answer is empty array. And then if the key has intersection, then I can build on top of this array, right? So I can do like plus equals, and then the value should be the minimum of those values, right? So okay, we can do like min value and then map 2 of key, right? Okay, what does that mean? It's in an intersection, right? So if there's like 2 2s and 2 2s, then we just pick 2. But if this was like 3 2s, then we still pick 2, right? Because this doesn't have 2. So which is why we're doing like minimum. Okay. All right. So the reason why I'm doing plus and minus plus equals is because in Python you can add stuff to the array. So that's why. And then let's just see if this works out. Let me just try to test it out. Okay, it didn't work. Oh, wait, sorry. Yeah, this is just gives me the number, but I have to actually add array, which is why like I have to do this. This is like the number, and then the square bracket is like becomes an array. But if I multiply it, then this also, which means if I do this, right, then it means this will produce 1 8 times. Let's just do 4. And it's just like that. So what this means is like, okay, given the array, I'm just appending this array, right? So now we're just extending array on top of each other. Okay, now this test works. And then let's just do a control enter. Okay, this works. Nice. Yeah, I wouldn't put too much emphasis on the milliseconds because this depends on the time of day, number of CPUs available in Leetcode, and also like the premium users have much more advantage in the milliseconds, and it will just go to 3. And then if you submit it again, it will be much different millisecond, right? So I wouldn't put too much emphasis on top of it. But in terms of like time complexity, this is O of n is time, and then of O of n as space, right? So that's the time complexity and space complexity. Because we're declaring dictionary, then that's O of n space, and O of n times is because we're just looping through the number lists again and again, and then there's no nested loop, right? So that's why it's O of n. Okay, let's just submit it again and move on. Okay, this time we're just kind of slightly faster, but I mean, like I said, just don't pay too much attention to this. Okay, so we're at 7. We spent 7 minutes in here, which is not great, but we'll just go on to the next one. Okay, what's this? You are given a string S. The score of a string is defined as sum of the absolute difference between ASCII values of adjacent characters. Okay, return the score of S. Okay, what does that mean? Okay, ASCII values are, that's self-explanatory. Okay, the score would be 1. Okay, I see. So that's that 108. Wait, adjacent, right? So it's like left and right. Okay, hello is like that. E is like that. Absolute difference between the adjacent characters. Okay, I see. Gotcha. Okay, let's just start off with like how do you do like ASCII in Python, right? So that we can just do like, I think it's called ORD. Let me just see if that works, and then return 0, just to test it out. Okay, yeah, the ORD gives me the ASCII values, which is great. And then this is like saying adjacent differences, right? So we have 5 characters, we have 4 differences, 1, 2, 3, 4, right? Okay, which means I have to do index-based loop. So instead of character-based, range length of S minus 1. So because we're, doing adjacency, I'm gonna do -1, and so which means I have to add the absolute value of s of I minus s of I plus 1, but we're gonna do the ORD, right, which is the ASCII value, like that, and then we're just gonna return the rest. Okay, let's see if this works. Okay, yeah, it works. Let's just submit this code. Okay, yeah, it works. So, okay, and then the time complexity and space complexity would be, time is O(n). O(n) is the number of characters in the string, right? And then the space complexity is actually just 1 because we don't have any extra space complexity in here. That's good. Okay, cool. All right, so that's 2 questions. So let's move on to the third one. Given 2 integers num and t, a number is achievable if it can equal to num after applying the following operation. Okay, increase or decrease the number by 1, and simultaneously increase or decrease num by 1. Okay, return the maximum achievable number after applying operations at most t times. Okay, that's kind of weird to understand. Let me see. So we have num and t is the number of times, and then apply the following steps. Decrease the maximum achievable number by 1, and then num by 1. Okay. Apply number of twice. Isn't it just like 2 times whatever this is? That's kind of stupid, right? But let me see. Because like if you can, maximum achievable number is like obviously you're going to add 1 and then -1 on the other. Okay, let's just try that and see if it works. Okay, so it's like num plus 2 times t, right? If I'm not mistaken, let me just see. Okay, maybe there's like a minus number. Okay, there's no minus number actually. The number is greater than 1. Okay, let's just see if this works. Okay, yeah, it worked. It's so dumb. Yeah, so just to explain this, right? Obviously the maximum number you want to subtract it as much as possible to maximize it, right? But for this num, you have to increase it 1 by 1. So you're subtracting 1, and then you're adding 1, and then you're just getting closer and closer. And then which means, every operation you do, the number increases by 2, right? And then which means it's like 2 times t. So that's why we're just doing this formula. And the time complexity would be O1. There's 1 operation, and then space complexity is O1 because we didn't use any extra space. Okay, cool. That's the third one, right? Okay, let's do the fourth one. Concatenation of array. Okay, given an integer array of nums length n, you want to create an array as the length of 2n, where a of n, ans of I is nums of I, and I plus n is also that index. Okay, I think I know what it is. Okay, gotcha. So it's basically like duplicating this array 2 times, right? Like this one, and this one. So it's like, copying, like not exactly copying, but just basically like, yeah, you can say copy, I guess. So you just extend this and then copy it to another. Okay, in Python, you can just do this like super easy. I think you just do this and that's it. Because that is the shortcut for Python. Let me just see if this works. Yeah, it works. Okay, let's just submit it and see if it works. This is kind of like cheating, but for good measures, let's just try to do it in good old-fashioned non-Python way, right? So let me just do like, okay, we're going to create a new array which has a size of length, so it has to be twice as big, right? Okay. And then what I do is for I in range of length of ants, well, I'm going to start copying, right? Okay, and then ants of I is equal to nums of I. Okay, so this is going to work until we reach the index of nums, right? But it's obviously going to be like index out of range once it hits that. So that's why we can do like something like length of nums like that. And then we can return the answer. See if this works. Okay, this worked. Let me just see that. Okay, now it's slightly faster, but again, I'm not gonna put too much emphasis in there. Okay, so what's the time and space complexity in here? Time complexity would be O of n, obviously, because we're just doing loops one time, right? It's 2 times n, but it doesn't matter in the time complexity sake, but it's just O of n for time complexity. And space complexity, so okay, this is kind of tricky. So if it's talking about extra space complexity, right, then it's just O of 1, because this is the answer that we want, and then we're just returning it, which is, we're not producing anything extra, I guess. But it's kind of like, but we are, using extra memory, like 2 times that. So I will just say it's O of n space complexity. But, this is like kind of debatable depending on, the restrictions, I guess. But in my case, it's O of n space because, we're creating new variable that is, twice as big as this one, and then we're just assigning it, which is, O of n space. Okay, let's just go to the next one then. Okay, this is the fourth one. So now it's even worse than the first one, right? Okay. Concatenation build array from permutation. Okay, this might be interesting. Let's just do it here. Or is it given a zero-base permutation, zero index, build an array as of the same length where oh, okay. I think I saw this before. There is a build as follows. Okay. 0th one. This is kind of difficult to understand. I think we just follow this formula and then we can just do it pretty easily. Right? So okay, let's just create like an empty array. That is like size of the nums, right? Okay, and then what I do is like just go over through the indexes, and then what I do is answer, basically like just copy this thing. So this is the formula, right? And then you can return the answer. Let's just see if this works. Okay, yeah, it worked. Exactly. So you don't have to get confused about this, but you can understand it for sure. But I mean, this is the formula that it's given. So let's just see if this makes sense, right? So we have nums like that, and then nums of I is, so let's just say I is 0, right? So nums of I is this, which means 0th index is gonna be the 0, which is this thing, right? Okay, let's go to the second one. Nums of I is 1 in this case, and then this is 2, right? So nums of 2 is gonna be the first one, which is this thing, right? So 1 is going to be here. So we can just understand that by that way, but you can just copy the formula and then just be done with it. And then time complexity would be O of n because we're looping through the array, and then space complexity would be also O of n because we're creating new array, right? This doesn't say modify the existing one, right? So yeah, that's why we're saying this space is O of n. Okay. Let's go to the 6th one then. Permutation difference between 2 strings. Okay, this one. Okay, what is it saying? You are given 2 strings S and T such that every character occurs at most once in S and T. Is a permutation of S. Okay, guess. The permutation difference between S and T is defined as the sum of absolute difference between the indexes of the occurrence of each character and the index of the occurrence in the same character in T. Return the permutation difference between S and T. Okay. I guess it kind of makes sense. Okay, so I think it's easier to look at this example. Okay, so basically what it means is like every character in S appears only once, right? Because otherwise there's going to be like confusion. So okay, this has unique characters and this has unique characters, but they're like permutation of each other, right? Okay, that's clear. And then the A is in position 0. In here, it's position 3. So we just do 3 minus 0. And then plus B is in position 1. And B is in position 2 in here. And then it's just like that. So it just keeps on and on like that. Pretty straightforward, I would say. And to solve this problem, I think it's, we can also do it like nested loops, right? But that's going to be like O of n squared to find each character position by index. But we can just do basically hash map, right? Hash map would give us like the positions instantly if we process it. Okay, and then we just do let's just do like map of s, right? And then we do default dictionary again, int, because we're storing indexes, right? And the map of t default and then for so we want the index and the character, so we do like not range, sorry, s enumerate s. Okay, so this is a really good trick where if you want the index as well as the value of the thing that you're looping, you just do enumerate. So this I will give me the index and c will give me the each character of this string, right? So this is the way you do for loops in Python if you really want index and the value together, which is pretty cool. Okay, so and then now we do like f of s of c is equal to I. For I, c in enumerate t, and then we just do the same thing. T of c is equal to I. Okay, so we have the both maps, and then we can just go through one of them. It doesn't matter which. Let's just go to a map of s, right? And then it's guaranteed that this key is going to be on the other one. So we're just going to do like, okay, we have answer 0, and then answer plus equals absolute value of value minus map of s of key. Return answer, right? So this is exactly what we want. The value is going to be the index, and also this is going to be the index, right? So we're just subtracting index by index. Okay, let's just see if this works. Oh yeah, right. This dot items. The default is going to be just key looping, right? But you have to do dot items to get key values. Oh, it's not correct. Huh. I think I messed up somewhere. So my output is 0, huh? Which means map of s. Okay. Map of t. Oh, yeah. This should be map of t. Yeah, okay. I wish this had highlights by default, but it doesn't, so I think that might be like a premium feature or something. Okay, now it's accepted. Okay, I mean, who cares? If I submit it again, it's probably going to be faster. Okay, so the time complexity is O of n, and the space complexity is also O of n, because we're creating two maps for each character and then index, and then the time complexity O of n is because we're just looping through each characters, right? And n in this case is going to be the length of s. Okay. That's that. And then move on to the next one. Permutation difference between, convert the temperature. Okay, let's see this. Convert temperature. You are given non-negative floating point number rounded to decimal places in Celsius. Okay. That denotes temperature in Celsius. You should convert Celsius into Kelvin and Fahrenheit. Return this in array. Okay. Return the array as answer within the 10 to the negative 5. The actual answer is accepted. Okay. I mean, it's just okay. I mean, it's pretty easy, I would say. Return. So Celsius. There's just a formula. We're going to return to Kelvin first. Okay. So the formula is 273.15, and then Celsius times 1.8 plus 32. Okay. I think that it just should work. Okay, yeah. So that's pretty straightforward. I don't think there's any complicated stuff in here. Just follow the formula. And then I guess in Python, you could just do this and initialize it and then return it, which is one of the benefits of Python, right? And then the space and the time complexity would be just O of 1, right? Okay, that's that. All right, let's move on to the next one. Convert temperature, final value of variable after performing, okay? Okay, so which problem are we in? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're at the 8th problem, okay. Oh, I think I've seen this before. there's a programming language that only has 4 operations and 1 variable x. Okay, so there's basically like a list of string, right? And then list of string has a bunch of operations, which is like has only 4 types of operation. And minus minus x is like decrements the x by 1, and then x plus plus or plus plus x is going to increase the value by 1. So it's here, right? So basically it's just after executing that, what's going to be the final value. Okay, so there are like many ways of solving this. You can do something like switch statement and then, you know, equal 4 things, right? But I think that's kind of unnecessary. The easiest thing would be to just do like, okay, the answer is 0 for operation in operations. Then if operation of 1 is equal to plus, then we're just gonna do add. And then if it's else, then it's gonna be like that. Return as. Okay, so the reason why I'm using index 1 is because we just have to get the middle thing, right? If this middle is minus, then, you know, it's going to be minus like this. It's going to be on the else state. But if this middle is going to be plus, then it's a plus. So so you can just see like both of these has like the middle has plus. So we don't even care what's in the first place or what's in the third place, right? We just have to look at the middle character and then see what happens. Let's just see if this works. So you can do stuff like, you know, switch statements and equal for things. You know, we can do something like, oh, okay, if the operation is plus plus x, or operation equals x plus plus, like that, right? But this is just too much. So you can just follow this logic and then just be done with it, basically. And then the space complexity would be O of n, because the n is the number of elements in the list, right? Operations. And then space complexity is just O of 1, because we didn't use any extra space. We didn't declare anything extra. Okay, that's that. Let's just submit this again. Okay, cool. Final value after defanging in IPI address. I think I remember this one. What is this exactly? Yeah, I never really understood what this problem is for, but I guess it's, you know, it's okay, I guess. So basically the idea is you have like a string that it has like dots in it, right? So which is, you know, representing IP address. And then you just replace the dots with like square bracket dots, like that. So in Python, you can just do something like address dot replace dot with that, and then it would just do it. I think that this should work. Let me see. Okay, yeah, it's just that. So in Python, you just do replace statement and then just complete this problem. No problem, with no struggle at all. Okay, yeah, it just beats the. I mean, you know, it's fine. This, not sure what are these, but that's fine. Without this, without the replace function, how would you do it, right? I think without the replace function, you have to create like a new string or like split it and then join it or something like that. Oh yeah, there's like that method too. So without replace function, you can do like address dot split with the dots and then join it again with these. But this is kind of like unnecessary. It's you know, better to use the replace instead of this one. Okay, like that. And then I would say the space complexity is O of n, because we're creating a new string, right? And then time complexity would be still O of n, because there's going to be a looping through and then replacing it for the replace function. Okay, and then, yeah, submit. Easy. Okay, that's what, 3, 4, 5, 6, 7, 8, 9. Okay, so the last problem. Number of good pairs. Okay, let's just see what this is. Number of identical pairs. Huh? Okay, so the function name is a bit different. Given an array of integers nums, return the number of good pairs. Okay, so a pair is called good if the numbers are, okay, I see. The numbers are the same, but the indexes are greater. Okay, so basically like, for good pairs, okay, so this and this is a good pair, and this and that is a good pair. So that's 2. And this and this is going to be a good pair, and also this and this is also a good pair. Okay, so that's like 4 good pairs then. Okay. So I think there's a couple of ways of doing this. One is definitely like doing nested loops and then just be done with it. Let me just see how fast is that. The other way of doing it is obviously going to be through a hash map again, but let's just do the nested loop thing. Nums for j in range I plus 1, because we don't want to start from the current index, right? We have to start from the next index until length of nums, and then pairs equal to 0, and then if nums of I is equal nums of j, right? No, not return, sorry. Pairs plus 1, return pairs. I think that should work. This condition is already implied because this loop is always going to be greater than, I mean, not loop, the j is always going to be greater than I, right? So we don't need to check this condition again. Okay, let's just submit this and see what happens. Okay, so this is solution 1, which, I mean, I guess it is pretty fast, but there should be like a theoretically faster solution than this to use hash map. So this solution is time is O of n squared, because we're doing nested loops, right? And then for space, this is actually 0, 1, because we're not creating anything new, new variable, right? I guess I should stop saying new variables, but I mean, I did create like one new variable here, but that's just one variable, right? So we're not, creating another nums variable that has a size of, the length of n or something like that. So that's why I keep saying there's no new variable. Okay, so that's solution 1. You can just comment this out. And then another solution is going to be just count the number of items. And then we can do combination equation, right? Okay, so for example, like if you have 4 items, how many combinations are there that's, doing 2 pairs, right? So that's like a combinatoric problem. But I mean, it's pretty easy. The answer is like, so if it's 4, then it's just 4 times 3 divided by 2. So it's like, if there's like n, then it's just going to be n minus 1 divided by 2. The actual formula of this is like n factorial divided by n minus k factorial, and then k factorial, right? So it should be like that. But if you do like, k is like the number of items, right? Number of items to group. So if k is 2, then this just becomes this thing. You can check this out for yourself, but we can just use this formula to count the number of pairs, basically. So let's just do that. Well, I'll just comment these out for future reference. Okay, so to count it out, we just do like, I guess let's just do count, which is default dict integer, right? Oh yeah, one thing to note is that I keep just using default dict in here, but if you use it on your own IDE, I don't think it's going to work because you have to import it from collections. So it's the actual code should be from from collections import default dict should be added on top of it to use it. And default dict is obviously like a Python's own library, so you can use it like this. But in Leetcode, it is automatically added, so you don't have to keep doing this. You can just leave it out. Okay, so for n in nums count plus, no, not this, plus equal 1. Okay, so now we have the counts. So after we have the counts, we just do the formula and then, get the answer. The reason why we don't care about this thing is because whenever you take 2 pairs, right, from any of the groups, 2 distinct pairs, obviously the indexes of the right one is going to be better than the left one, right? So this condition is kind of like meaningless in that sense if it's two distinct numbers. So that's why we don't really care about the order. So we just need the count of things. Okay, so we got the count, and then we just go through key value in the count map items. And then what happens is like, so we have pairs as 0, right? And then we should be careful with one edge case. If the count is 1 or less, right? We don't care. We just skip it basically. There's not going to be one or less, but if it's just, just precaution, I guess. So we can just continue. No, okay. So now if it's greater than 2 or more, then we just do the formula, right? So pairs plus equals value times value minus 1 divided by 2. Turn pairs. Actually, in that sense, we don't really need the key, so we can just delete this, and then instead of looping through items, we could just loop through values. Okay, let's just see if this works. Okay, yeah, it worked. Okay, let's see if it's actually faster than the first one. Sometimes it's not because, there's, guys, it is slightly faster. It's theoretically faster, and practically it's not going to be faster in most of the cases because, creating dictionary and getting the values of the dictionary and stuff like that, it's going to take a while. So if obviously the test case, if it's large, then it will make a difference. But, in Leetcode case, in 3-4 millisecond difference, no one cares. Okay, this is the final problem then. Then we have 24 minutes to spare. 25 minutes almost. Okay, I guess this challenge is, completed in this session. So the reason I kept it in 10 is because in the future videos, I'm sure I'm going to struggle because these 10 problems were not that hard, right? But as we move on down to the list, it gets harder and harder. So I'm sure there's going to be a struggle someday, but we'll see. But for now, we're just going to do it this way. And then hopefully, wait, did I not submit this problem? Build array from permutations. Okay, I guess I didn't submit it. Let's just submit it. Okay, let me refresh it again. Okay, so we have 1, 2, 3, 4, 8, 9, 10. 10 problems completed. And this is solved, right? I guess this is because this is today's challenge or something like that. Oh, wait, what? What happened? Oh, did it change? Wait, minimum difference between largest and... Okay, wait. I think I messed up then. So this top one is always the daily challenge then. So, wait, I solved one problem, right? Insertion of 2 arrays. Okay, I guess I messed up and solved the daily problem. Okay, whatever. Let's just do I'll just start. Okay, maybe I should stop. I did solve 10 problems though. Okay, let's just keep it like this, and then we're just gonna move down. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we solved 10 problems. One of them was a daily challenge, and it was apparently like an easier problem. And then this daily challenge just got reset while we're doing it, I guess. So that's what I think what happened. So I mean, okay, that's it. Whatever, man. Okay, so on the part 2, we're just gonna keep solving 10 by 10 and here, and then let's see if I can struggle or not. And then there's gonna be like a medium problem or a hard problem video in the future, and then hopefully I'll be able to do the challenge. But the hard problem is gonna be super difficult. Medium problems, I think I can do with a little bit of struggle, but getting to optimal solution is also really hard. But easies, I think easies is really, really doable. So yeah, that's about it. And I hope you liked it. And then, leave any comments, questions, concerns down below. All right, see you.